Hello everyone, my name is Adam Walker, and for my final project, I made a half-scale bowling machine, or at least the beginning of it. Specifically for this project, I made the scoring component for the final project, and then, so there's two main parts to this project. So the first part is the thing that's actually going to set down half-scale bowling pins, which I'll show a little bit later what I've got so far on that. That will be powered by an Arduino. I'm using Arduino Mega. That uses a variation of C language, and that will be able to directly communicate with motors necessary and the switches necessary to set down pins. And then it will also be able to communicate back and forth with the second component, which is the computer component, which uses Java. And that is what I'll be primarily showing in this presentation. The computer component, like I said, can talk directly with Arduino, and the computer component is what people will see. So it will be the scoring system for the bowling machine. So if you've ever gone to a bowling alley, there's, of course, whenever you throw a ball, there's a machine that sets down bowling pins. That will be the Arduino side of things. Then there's the touch screen where you input your names, and then there's the 10 frames that display on a nice interface. That is the Java component, which is what I'm doing specifically for this final project. So, like I had said, they both communicate with each other using serial communications. So what's nice about an Arduino, I'm going to pull up just real quickly what an Arduino Mega looks like, just because a lot of people are not familiar with it. So what an Arduino is, if you don't know, it's a programmable microcontroller. So what that means is you have all these pins along here, and you can turn them on and off using code. So there's a little CPU on there, there's all these pins, and for instance, if I connected an LED to one of the pins and to ground, then I can turn on and off that LED with code. I'm using this to do motors, read switches, etc. There's also a little USB port which can directly connect into a computer. So getting back to this, present, if it'll work, I'm not sure what that is. Okay, so they're using the serial communication. Basically, all you have to do is select a serial port, and somebody's already made a library that will let you communicate over serial. I'm not sure what happened there. Okay. And communicate over that USB port that already exists. It's called serialcom.java. And I found it quite some time ago, so I hope this is the right one. There's multiple out there, but this is the one I use, jserialcom. And there's just very basic documentation here. Not the greatest documentation, but it works. You can import, or you can get the communication ports, and it'll display them. And there's some other documentation here. I'll get into that a little bit later. But pretty much, you can easily communicate back and forth using, some of the stuff that we're used to, like scanning for the input, for example. So what I'm sending back and forth, I'm sending commands back and forth. So I'm sending commands back and forth. I just had to pull up the window real quick. So these are all the commands I'm able to send. So I have, first of all, to do a cycle. So what a cycle is whenever the pinsetter comes down and does something. So for instance, after you throw a shot, if it picks up pins, or if it sets down 10 new pins, that would also be a cycle. I also have a cycle, a gutter cycle. So if you only knock down, say you knock down or you throw a gutter ball, basically, it doesn't have to pick up all the pins. It can just raise, and it's just a shortened cycle. And then the last cycle I have is a selective reset, which would be if I only want to set down, say, the 7-10 split. Then I can just send arguments, and it will it will only set down those pins. In addition, we'll send scores back and forth. So, and with the S command, which would be like it would send pinfall data. So, for instance, it would say I should probably pull up a chart of bowling pin numbers. So just so that we're all on the same page. So I had mentioned this. I can set down, say, the 7, 10, and it'll only set down those pins. Say you knock down all except for the 10 pin. I can also, so the scoring data for that would be, it would send back a command in which all of these are zeros and the 10 pin would be a 1. So each command begins with a beginning character. So I believe I have it set for tilde. Then say you want to do a scoring command. So this is going to be like similar to what I would type in. So, or what is going to be sent back and forth. So I'll do a cycle one first. So C would be for cycle, and say I want to do a selective reset cycle. I can send, or I'll start with the reset cycle. I would send C0, then there's going to be some sort of hash code, which I'll go over the algorithm for that a little later, and then you have some sort of ending character. I don't remember what I set for that, so I'll just use an equals. It's a constant in the program. I don't remember exactly what I used. The program waits for that character. When it finds that, it keeps reading until it finds the termination character, and then it will start reading the command. It will verify the command using the hash code, and then it will try to interpret the command. So C0 here, the hashtag would be any other ASCII character that would be the hash code generated. So C0, it would read the C, it would see that it's the do cycle, and it would see the 0, the argument, and it would do the reset cycle. If I wanted to do C3, which would be a selective reset, then I could say, if I want to set up the 7 and the 10 pin, the 1 through 6 are not up, so those would be 6 zeros. 4, 5, 6, then the 7 pin I want up, so I would send 1, then 8 and 9, zeros, 10, 1, then whatever the hash code would generate is, and then the determination character. Scoring works very similar to this command, except it would be an S, and then it would just send which ones are up. So say you left, let's say you only knocked down the 4, 7, and 8. So 1, 2, and 3 would be up, 4 would be down, 5 and 6 would be up, 7, 8 would be down, 9 and 10 would be up, and hash code and termination character. So that would be the 4, 7, and 8 are knocked down, and so that would be if the person knocked down those 3 pins. So this is kind of what is sent back and forth. I have a few other commands here. So you can send errors back and forth. So if you've ever gone bowling and the machine is shut off, I can do the communication between that. So if some sort of error occurs on either end, it can shut off and it can provide feedback on the display. That hasn't been completely implemented yet, but that will at least in the future be able to be the case. I have P, which lets you change the power state, so turning the machine on and off. Q is a message that the Arduino sends to the computer saying that the power has been changed. D is sent whenever a cycle has finished, so meaning it can perform another cycle if it would want to. And if you notice, letter after P is Q, letter after C is D, so that's the reason why I chose that. L and M is the same thing. L is for the light that lights up everything, and then M is for the light was changed. And then just 0 is if a command was sent incorrectly, it will resend it. So kind of going back to my presentation here. This does use an external library, as I had talked about earlier, and these are all the cycles I've been talking about. So there is a hash code. I'm only using an 89. Number 89 is my prime number. So this is not exactly ideal. It would be nice if it was larger. The reason why is because I was trying to make it a one-character ASCII code, and a lot of the stuff on the ASCII table at the beginning is tied up with really like the term or null terminator, for example, I wouldn't be able to use as a hash code. So I chose to start my first hash. I chose exclamation point. My last one I chose the pipeline. Hash prime is 89, and if I find hash, should be someplace here. See, gen hash string. Okay, here it is. So it's based on both the position that it's in and what the actual character is. So, for instance, going back to my example here, this command, and if I switched the 0 and the 1 on here, if somehow that got switched, although these would have the same ASCII codes, they're in different orders, so they would generate a different hash code. So that is a hash code. That is how I'm verifying commands, and it will try to resend the commands back and forth using that 0 command if things are incorrect. So this was kind of the most difficult part of my program to get this correct, and this is what I spent the bulk of my time on, because there's both sides to it. Although for the purposes of this class, I'm only doing the Java component. I had to also write a very similar part in the Arduino side that would read the commands that on the Arduino side, it would read the commands that the PC had written, and vice versa. So I do want to kind of play what I've made, the engineering component. The engineering component is made in, it was 3D printed. All parts are original and made by me. And my dad helped me with the wooden frame. So as you can see here, these are exactly half-scale pins, just kind of backing up here. So I do have all 10 of them. There's these grippers, and these are controlled with motors, and this whole entire apparatus shifts up so that the pins are not horizontal, but then they become vertical. And I'll just let you play. So the whole entire thing becomes vertical. Then in the future there'll be a motor that will drop it. For now, this is totally manually driven. I have the code done, but I don't have the wiring done. You can see I'm moving the wheel back there on all of them, and it's moving the little grippers up. So if I go back, you can see that these are up. So I'm just going to skip ahead a bit because all I did was I undid all 10. And then now the thing will come up, and all 10 pins will be set. So in the code, I will be able to manually control, or I'll be able to control all of these servos. So it will be all automatic once I get all the wiring done. I've had some difficulty with that. But pretty much what I was talking about with the selective reset is if I wanted the 7 and the 10 pin set, all of these would stay the same, and all I would do is activate the motors for the 7 and the 10 pins, and it would set down those pins, and all the rest would stay above and would not be set. So now that kind of gives a general idea of the program, or what I'm trying to accomplish. I will show you now the other component, so the actual Java component. So I made it in Eclipse using Java. If I run it, so the first thing that pops up is you're choosing the serial port. So every USB port, or everything connected over USB, is going to open up a different serial port. So in this case, there's just Bluetooth here. I'm going to plug in my Arduino. It's not actually connected to the Pinsetter. It's just the Arduino on its own, and I can send some dummy scoring information. So I'm going to hit refresh, and now it popped up. I can choose either one of these. I'm just going to choose that one. I'm going to open up the port, and I'm going to just type in, let's say, well, my name's Adam, and I'll just leave it in second player high. If I hit begin game, so that's the game setup, begin game, and it will make a scoreboard, and with all 10 frames. So for now, there's also the second window. So I do have some debugging stuff here. The open and close buttons are no longer used, but I can send a command. And so this will be stuff like, if I want to turn the power off, I would do P0, and it will turn the power off. And you can see the Arduino sends back Q, which is the notification command for the power being shut off, and the PC reinterpreted Q0 as power state was changed to off. So just kind of going over this. So it's sending the command P0, then it's beginning to read the serial because it found stuff. Actually, I set my beginning character to be the curly bracket, Q0, exclamation point is the hash code, and then the tilde is the termination. So it recognized that that was the command. So even if I had gibberish in front of this or gibberish after, it would just isolate it to that. And it verified the hash code was correct, found the command was Q0, and recognized that it was power off. So P1 will do the similar thing. You can see a different hash code. So what I set up was, for the purposes of this, since I don't have the entire thing operational, I made the Arduino able to send back dummy scoring information. So if I send the command U, lowercase u, just a random letter I chose, it will randomly generate scoring data that will fill in the scoreboard. So if I send the command, it generated a 3. So you can see that the Arduino, so I sent the command U, the Arduino sent back that I just changed the amount of pins in front. So it sent that the first 7 pins were up, the last 3 were down, and the hash code was D. So it recognized that command, it added the score, that's the pinfall, and then it also sent back the cycle that would be done. So it sent back, in this case, you would respot the pins. So you would pick up all the pins, and it would sweep any pins as necessary, and then it would be ready for the next wall. So now if I hit it again, send it again, it randomly generated that there were actually 2 more pins standing, which would be impossible. So it added a minus, and then it said the score is it interpreted it, and then now it's saying it will do the reset command, which is setting 10 new pins. And then so I can do that a few times, and as you can see, it will calculate the score with spares and strikes as necessary. So for instance, I have a 1 spare here, and it is going back and forth between them as any other game would. The 1/, it's not going to fill in the score until it knows what that is. So that would be 51 plus whatever's in there. So it's generating 1. So 41 plus 10 plus 1 would make 52. Then plus 1 would make 53. And then it can just go on like that. And I even have the 10th frame working. The 10th frame was a little difficult. I believe this actually generates the same string of numbers, so I'm going to go ahead and X out. So I believe if I actually generate it again, it will show the 10th frame working. The 10th frame gets a little bit complicated because what will happen is in the 10th frame you could have, for instance, a spare and a strike. You could have a strike and a spare. You could have 2 strikes and another something. You could just leave the frame open, so get a 9 and nothing. So there's a lot of options there, and you have to make sure that you're only giving the player 2 shots and you're calculating the score correctly. So I'm just going to fill in this. Yeah, as you can see, it started with a 3- again. I didn't salt the random. Or seed the random, sorry. So, taking care of the spare there, and it got the score of 99. So now that gives an idea, and this is just the debugging window where I can send commands. So now that gives an idea of what my program does, I guess I can kind of get into more of the code. So I do have a ton of UML diagrams. There's a ton of classes in this. I would actually like to. I feel like it would make more sense if I jump around a little bit. So I apologize for Mr. Mayo grading this, but this is the window that will make the most sense. So I kind of going smallest to largest. I have a single frame. So this is like the 3-, or like just a spare that the player threw. So I'm going to just open up one more time. Oops. Sorry. Okay. So if I just send that again, yeah, it's generating the same thing. So this would be a single frame. That's also a single frame. That's the smallest unit. Then from there, I have a player, which is storing all 10 of these. Then I have the scoreboard, which is what you're seeing, which is just a graphical interpretation of what it's storing in arrays. Then from there, you have run scoring, which is kind of like a driver for running multiple players and having all the player, like changing between players as needed. So if you have 2 bowlers, making sure that it alternates between the bowlers. Cycle is what takes care of calling, like running or asking to run the commands, making the windows, calling run scoring for the first time, and then you have your driver, which is just basically all it does is it tells cycle to start going. So going back to kind of the UML diagrams, there's a lot here. So I'm going to just kind of sum up each class. So you have your 2 drivers, bowling score driver. I didn't, that was mainly at the very beginning whenever I wasn't worried about the Arduino communication, whenever I was first making the window for displaying the scores and trying to make sure the totals make sense. That's actually deprecated. I'm no longer using it. This is the run-dependent scoring driver. That is the driver that is currently running. It's basically saying it's telling cycle to, establish a connection and start scoring. Then you have run scoring, which cycle calls. That's, like I described, you can add a score to it, and it will make sure it goes with the correct person. And then you have your comms commands, which is it handles the interpretations of all commands, and it handles it telling the Arduino to do cycles, reading commands, generating hash codes, everything like that. And you have a window you have a class which is just a single command, which comms commands uses. So you have the type of command, which I believe I left these public. Basically, the comms commands just has an array of every single command possible. So the P, the Q, L, M, C, S, all the ones I had mentioned earlier. So you have the type of command, you have whether there's anything after it, arguments, stuff like that. And then the next part, you have, there's your bowling frame, which is just a general outline of what all frames have in common. You have normal frame, which inherits bowling frame, and then that actually fills in everything in the interface. I'll get into why I chose to do that. And then you have 10th frame, which uses normal frame and adds third ball stuff, and overwrites how scores work. From there, there's also player and a normal player, which each has 10 frames in it. You have the scoreboard, which is the graphical interpretation of like the window you would see, as the user would see. Player scores is for updating the scoring graphic on scoreboard. And I believe that's actually inside the scoreboard class. It's a class within a class. Oops, I think I went back. Okay. So I pretty much went over the use of the classes in all the projects as I was explaining it. So you have your frames, you have your drivers, commands. I did have an original comms commands that I had to get rid of. I went ahead and kept the file, but it's no longer in use, kind of like the bowling score driver is no longer in use. And then I went over all of that. The class interaction, I went over that. Just the smallest to largest. That's how it works. The cycle, and the one thing I don't think I specified is that the cycle does make the settings in the commands window. So the settings window is where you type in your name, and the commands window is where it is the debugging, which won't actually be on the finalized version, where I was typing in the U command, or I was typing in turning power on and off, or scoring. And that's just for debugging. So the inheritance hierarchy. I do have two examples of inheritance. I'll go over the frames with the use of the interface. Working with player, first of all, I have an abstract class named player, and then I have a normal player which extends player. Basically, the player is always going to have multiple frames, or is always going to contain at least one frame, I should say. There are, most of the time a player is going to have 10 frames, but I might want to implement some sort of shorter game, or like whenever I was bowling on League, there would be at the beginning you'd be able to practice, and it would just be one frame that it would display. So that would be a different implementation, or different inheritance of player, where I would overwrite it and only have one frame as opposed to all 10. And if I was doing a no-tap game, so for instance, if you knock down 9 pins and I wanted to count that as a strike, it gives me more flexibility, while still having attributes that all players have in common. The other use of an interface is I have just the bowling frame, and normal frame, which has 2 shots in it, and 10th frame, which should have 3 shots. So, and this once again allows for more flexibility. So the use of, I'm going to go back to the UML diagram. So there's always going to be in a frame a first ball and a second ball. But how you calculate the score might change. In not a normal game, but if I wanted to implement like I said earlier, where like if you knock down 9 pins, it would count as a strike. That would be a different implementation of, instead of bowling frame. Instead of normal frame, I would name it something else. And so this is what all frames will have in common. Then 10th frame is going to have it has to overwrite how the second ball works, because sometimes depending on how the user finishes their game, the game might or might not end with the second ball anymore, versus the frame would always end before with the second ball. now there's opportunity for the third ball. So that is that example of inheritance. So once again, there's the player inheritance and there's a frame inheritance. So polymorphism, pretty much like the most obvious example of this is whenever with bowling frames. So I do have multiple arrays that contain just a list of normal frames. So, but it would contain, there's also the 10th frame at the end. So I'm storing it as, I'm adding it to the array list as a normal frame, like with the other normal frames, and then I'm addressing it later in the 10th frame. And that's used throughout that single class. I need to remember which one that was in. Would that be in scoreboard? Don't feel like it is. Wait, hold on. Either normal player or player should be in here. Yeah. Yeah. So you have the game that stores that, and if I'm adding a score, it has to, if it's the first ball, it would have to add another frame to the array, and if it's the 10th frame, it will add a 10th frame as opposed to a normal frame to that. And so that would let me use the normal code for adding the first ball, since the 10th frame, the first ball of a 10th frame and the first ball of any other frame is going to be identical, and same thing for the second ball. So you can see here I just have set first ball, and whether that is the 10th frame or whether that's a normal frame, it doesn't matter, it will run it. So that is my example of polymorphism, and it's used throughout this class in order to make the game work. So I'd like to take a break here before I do that and go over, just show that I have all the requirements. So it might take me a little while to just Command F through everything, or Control F. So I'm going to start with wrapper classes, which is going to be integer and double. So that should be, I believe if I go to normal player, I have actually implemented it. This one should be actually be, yeah. So I have an array list using the wrapper class integer right here, and that will store the totals for frames. And then the next one, relational operators. So this should be a fun one. So there's one. Let's see, do we have a less than or equal to? Do we have a greater than? Not looking to promise. Cycle is going to have a ton of stuff. Let's go greater than or equal to. Let's go not equal to. So there's an equal to. So less than before, the equal to here, or here. See, there should be quite a bit. Apologize for not having this exactly together. So we're up to 3, I believe. Let's see if player has a ton of commented out code. There's a greater than. I believe that makes 4. So we have the less than, we have a greater than, we have an equal to, we have an or, we have one more. Greater than or equal to right here. And this class here is used this is to add a score to the game. If then and else, if else, while/for. There were a ton of other for loops that I guess I was in cycle. For. This is going through all the serial ports in order to display the serial ports on the screen to choose. One interface and 3 classes. I went over earlier, so we have bowling frame, and then we have an abstract class. We have player, which is abstract. We have all of these classes here, and then we have a driver, the 2 different drivers. An interaction between classes, went over. Inheritance hierarchy, went over. Interface, went over. Polymorphism, went over. Array list with iterator. This might once again take me a second to find. This is player. Here it is. So we have an iterator and it's iterating through frame, and it's getting the scores. And then documentation comments above each method in every class. We have all that. We have comments to end every curly brace. Just clicking through, there's a ton of comments. Meaningful variable name, same thing. Player scores, the current total. I can click through randomly, and it's going to be pretty good. Graphical user interface, I was showing before. So there's the screen where you choose port and write your name and the window to display the scores. And Java docs for the functions, or methods, sorry. So back to my presentation. Special features. So unlike probably a majority of people in CS, I did do an engineering component also. So this was a little risky. It took quite a bit more time, but it interacts with the physical world, which is what I really like. Seeing stuff on a computer screen is cool, but seeing stuff actually do something in real life is, I think, really amazing, and makes me much more motivated to code. I do have some special features, like more specific special features. I have that it checks that commands were properly sent. It won't just do something and hope for the best. It uses a hash code to confirm that the command makes sense, and it always asks for a resend if something's not working. You can choose which pins to set, which is something that not even some pinsetters in real life have. Like some full scale don't even have that, which is going to be really, I think it's going to be really cool. And then you can have multiple bowlers, like any other bowling game. Multiple people can bowl, and most importantly, I'm very far from finishing the engineering component, and all of my code is very expandable. So I have what's like a very basic start, but I can expand that to with extra commands, or if I need extra pins. So whenever I connect extra motors, it'll be very easy to change because of the way I have the classes set up, and things so modular. And of course, right now I'm barely getting it to set down pins. In the future, it would be nice to have the thing fully automatic, where I don't need to touch it at all, and it'll just go. Oops. So known bugs. What I have found is whenever it's first establishing a serial connection, basically the whole entire thing will go dead for a few seconds. So, for instance, if I have servos, the servos power off for a couple of seconds, and it's like the board gets unplugged. So I'm not sure if there's anything I can do to combat that necessarily, but it's just, and it's something, it's not that big of a deal, but it just takes a couple of seconds to establish the connection. The thing I do want to change is if the USB cord gets yanked out by somebody, then I have no way of seeing that. So the scoring does not tell me. It'll just try to send the command, and it won't. They'll send it nowhere because the serial connection is closed. So I need to. So that's kind of one bug. It should reprompt you to choose another serial port. There's also no way to bowl multiple games yet. So this is more of features to add in the future, not so much current bugs. It honestly, like, the code component works fine. It's the engineering component that I'm struggling with more. But in the future, I would like to make it where you can reset the game or bowl multiple games. And it also include some stats, a little picture of which pins you've knocked down, skipping bowlers, if you want to edit your score, if you want to change your name, all kinds of stuff like that. That is common to most full-scale bowling scorings in real life at an actual bowling alley. So the engineering component-wise, on the pin holders, of course I don't have the wiring done yet, and there's quite a few that aren't working. So I have little motors on the back of each pin, and a lot of those die very quickly, so that's kind of one bug. I need to switch out a few of those motors. I also need to print quite a few more parts and just finish the thing and make it automatic. Second party code, so I mentioned how I did not program the thing that will do the serial communications. Somebody already made that. So the rest of the code was original on both components. I did copy and paste a lot between the Arduino and the Java component, but a lot of it is very similar. And then also all the parts I 3D printed. I designed the components with the exception of a couple of wheels on the back of each pin holder, which I heavily modified. And those I found on an awesome website called Thingiverse. Basically, it's a site where you can share what you've 3D designed, and it will, and you can share it with the world, and then other people can download it, print it out, modify it, upload a new version, all kinds of stuff like that. Where did it go? Okay, and if you have any questions about my project, and if you want to see the progress in the future or whatever, I believe this video will be uploaded to YouTube. You can comment on there, feel free. Also message me on Facebook. You can find me on Facebook. I used to have a cat with goggles, now I'm not. It should pop up, especially since everybody watching this is probably at ATech. Or just email me, school account, or adamwalker567123@gmail.com. So, in conclusion, the features everything that I've tried to implement in the code works pretty well. Specifically, the commands works great. That was the biggest thing I wanted to get done. And it's able to display some basic scoring information, basic scoring interface. And also, I have the engineering component. It's able to set down pins. I just don't have the way for the two to interact yet, so with wires. So that is the status of my project so far. I look forward to continuing to work on it. Thank you for watching. Hit that like button. Thank you.